Hi everyone, in this video I'm going to compare absolute advantage with comparative advantage. And I'm just going to use as an example the information in this table here. So this table tells us about Larry and Susan who can produce engines and batteries. Now the numbers in the table will tell us about the maximum amount of each product that either of our agents can make if they dedicate, let's say they have 10 hours towards the production of each good. So if Larry spends all their time making engines, so they put the whole 10 hours towards making engines, they can make 10 engines. If Larry instead spends all of his time making batteries, he can make 5. If Susan spends all of their time making engines, well, Susan can then make 6 engines. And if Susan spends all of their time making batteries, they can make 4. Now, when an agent has absolute advantage, it just means that for a given amount of resources, that agent can make more of the product in comparison to another agent. So we can see from our table here that Larry has the absolute advantage in the production of engines and actually also in batteries, because Larry can just make more of both in comparison to what Susan can do with his 10 hours of time. So Larry can make 10 engines, but Susan can only make 6. And Larry can make 5 batteries, whilst Susan can only make 4. So Larry has an absolute advantage in both engines and batteries. Now, comparative advantage is different. An economic actor will have a comparative advantage in the production of a good if they have a lower opportunity cost. And again, we're going to compare this to another agent. And here, opportunity cost is the value of the next best foregone alternative. So it's the value of the thing that they give up when they choose a specific option or pathway. So in these sorts of examples where our economic agents, so Larry and Susan, can only do 2 things, they can either make engines or batteries or perhaps a bit of both. For our agents, the opportunity cost of making, for instance, 1 engine will be in terms of how many batteries that they will have to give up as a result of making that engine and thereby dedicating some of their resources towards making that engine and not towards batteries. And likewise, the opportunity cost of making 1 battery will be how many engines that they have to give up as a result of making that battery and dedicating some of their resources towards the production of the battery and not towards engines. And we can actually see that our table reports opportunity costs quite directly. The table itself tells us that, for instance, if Larry makes 10 engines, he's spending all of his time on making engines, and so he's spending no time making batteries. Now, if he spent all of his time making batteries, he could make 5. So we can tell from our table here that when Larry makes 10 engines, he's essentially giving up 5 batteries. So the opportunity cost for Larry of making 10 engines is equal to 5 batteries. And this is perfectly fine and great, except that when we calculate opportunity costs, it's customary to report opportunity costs in terms of making just one of the good. And this allows us to compare our opportunity costs between individual actors later. Now, in order to normalize Larry's opportunity cost to be in terms of 1 engine, I'm just going to divide 10 by 10, so that's equal to 1. But I'm also going to divide 5 by 10 as well, and this will keep the ratio of the trade-off correct, which is what we want. So we can see here I've normalized the number of engines to be in terms of 1, and we can see that Larry's opportunity cost of making 1 engine is half of a battery. Now we can do the same thing for batteries for Larry. The table is telling us that essentially the opportunity cost for Larry of making 5 batteries would be, well, he would be giving up 10 engines. Now, if we divide 5 by 5, that's equal to 1, but we'll divide 10 by 5 as well, and we get 2. So we see that Larry's opportunity cost of making 1 battery is equal to 2 engines. All right, let's do the same thing for Susan. If Susan makes 6 engines, they're spending all their time making engines and no time making batteries. If she instead spent all of her time making batteries, she could make 4. So the opportunity cost for Susan of making 6 engines is equal to 4 batteries. Let's normalize this to be in terms of 1 engine. So 6 divided by 6 is 1. 4 divided by 6 is 2/3. So Susan's opportunity cost of making 1 engine is equal to 2/3 of a battery. We can then think about Susan's opportunity cost of making batteries. So our table tells us that Susan's opportunity cost of making 4 batteries will be equal to 6 engines. Let's normalize that to be in terms of 1 battery by dividing both of our numbers by 4. So 4 by 4 is equal to 1. 6 by 4 is equal to 3 over 2. So Susan's opportunity cost of making 1 battery is equal to 3 over 2 or 1.5 engines. All right, so we have our opportunity costs here for each good across both of our actors. And you can see that Larry's opportunity cost of making 1 engine is equal to a half of a battery. That's how many batteries he gives up if he makes 1 engine. While Susan's opportunity cost of making 1 engine is 2/3 of a battery. Now, 1/2 is less than 2/3, so Larry then has the comparative advantage in the production of engines because when he makes 1 engine, he gives up less battery relative to Susan. If we compare Larry and Susan's opportunity costs of making batteries, you can see that Larry gives up 2 engines if he makes 1 battery, whilst Susan gives up 1.5 engines. Now, 3 over 2 is less than 2, so Susan actually has the lower opportunity cost, so the comparative advantage in the production of batteries. And you can see that even though Larry has the absolute advantage in the production of both goods, he only has the comparative advantage in the production of engines, whilst Susan has the comparative advantage in the production of batteries. So even though Larry can make more batteries than Susan, given his 10 hours, when Susan makes 1 battery, she gives up less engines, so her opportunity cost is lower, and that's what matters for comparative advantage. Now, whilst we can see from this example that it is completely possible for an agent to have the absolute advantage in both goods, what you won't see is an agent having a comparative advantage in both goods. Rather, really, the only other case that you might see is if the numbers in our table are such that the opportunity costs are equal, which indicates that no one has a comparative advantage. So if the numbers were like this, and this 4 was a 3, and you can check and calculate for yourself, this will come out as the opportunity cost being the same. So in this case, there would be no comparative advantage. But Larry would still have the absolute advantage in the production of both goods because he could still just produce more than Susan. And that's really it for this video. I hope that the video helped. If it did, please like and subscribe. You can also now visit me at www.econhelp.com.au for more resources to help you study economics. Hope you guys are doing well. Thank you so much for watching my stuff.